I'm going to try to make this video short, simple, and to the point. The way I see it, the big problem with physics is that there have been a lot of premature, cheap, and ultimately ineffective solutions to problems which are coming about from mathematics. And these solutions end up creating more problems than they solve, which in turn creates more intellectual activity, more problems to work on, and is good for the field in general, but not good if you're trying to actually get closer to truth, obtain knowledge, and actually finally solve problems. So I have a few examples of these in mind. I'm not going to go in depth into it just because I want to make this a short video. One such poor solution is the what we call quantization. So the problem with the original Jeans box model of black body radiation, which led to the ultraviolet catastrophe, it is said was solved by a mathematical trick that we call quantization. But I explain this in the book, and I go into this elsewhere, but it led to many more problems than it solves. It's akin to, all of these solutions are akin to the pills that we get from the medical profession. They solve a superficial problem, a short-term problem, but not in a very deep way, and they end up causing side effects and dependency, which is not good. The second example, in Einstein's moving light clock thought experiment, there's an apparent paradox which is resolved with the idea of relativistic time dilation and relativistic length contraction. This is a 2-for-1 kind of solution. But this ends up creating far more problems, loose ends, more paradoxes in the long run. Another one is the solution to the apparent flatness of the galactic rotation curves, which is that the stars and galaxies are moving at the wrong speed. We can't explain why they're moving at the speeds they're moving at. And dark matter is another fudge factor that was introduced to account for this. Of course, we have no idea what this mass could be, what's causing the equation to balance out or to appear differently than we would expect. But once again, this is another mathematical solution which just creates more questions. Another example is relativistic inertial mass increase. So one of the problems with Einstein's special theory of relativity is that a moving object would appear to violate the conservation of momentum. And the way around this is to say, well, maybe the mass of the moving object increases in some sense. Not in any absolute sense, but in some relative sense. This is just a cheap mathematical fix, and it ends up, as I demonstrate elsewhere, it ends up creating far more problems than it solves. So those are 4 examples. As I say, it's kind of like, the funny thing is these examples are all at the foundations of physics. So we've gotten used to them, we've just accepted them, and there are better alternatives.